In this video, we are going to apply what we have learned so far about transversals and the angles formed on each intersection. Before we proceed to the problems we will solve after a little while, let us have a brief review on the four types of angles found in a transversal. Before we can draw a transversal, we first need a pair of lines, and the most common we use in geometry are parallel lines. Let us now draw our parallel lines. By using this ruler, we can be certain that the two lines will be parallel. Now we have two lines, and as we can see, they are equidistant to each other, therefore they are parallel. We can now draw our transversal. And that is our transversal. Let us name the two lines as line M and line N. For our transversal line, we will name it as line O. Because transversal passes through or cuts through the two parallel lines, two intersection points are formed. Let's name the first point as point A and the second point as point B. For each point, four angles are formed. For our first point, point A, we have angles 1, 2, angles 3, and 4. For our second point, point B, we have angles 5, 6, angle 7, and 8. Now we have our 8 angles, 4 angles for each point. If you can still recall, we have 4 types of angles formed in each point on a transversal. These types of angles are the following. First, we have the corresponding angles. Second, we have the vertical angles. Third, we have the alternate interior angles. And lastly, we have the alternate exterior angles. The corresponding angles are angles found on the same position or the same location on each point. Let us take for example angles 2 and 6. Obviously, they lie on different points. Angle 2 is found on point A, while angle 6 is found on point B. Even though they lie on different points, you can observe that they are similar on the location or the position which they are found on their respective points. Angles 2 and 6 are both found on the upper left portion on the point which they are located. Angle 2 is found right here. This is our angle 2. In point B, angle 6 is found right here, the same spot or the same portion or in the same exact position on which angle 2 is also located. That is the meaning of being corresponding angles. Corresponding angles are said to have equal measure. So since angle 2 and angle 6 are corresponding angles, they are also equal in measure. So we can say that angle 2 is equal or congruent to angle 6. Following the same logic or reasoning, or following the same pattern, we can say the same for the three following pairs of angles. And these are angles 1 corresponding to angle 5, 4 corresponding to 8, and 3 corresponding to 7. So all of these 3 pairs, the same as the first pair, are congruent or equal in measure. So let me write it all down. And now we have the 4 pairs of our corresponding angles. What about vertical angles? Vertical angles are angles that lie opposite to each other, or angles that face each other. For example, angle 1. What is the angle that is opposite or is facing angle 1? We have angle 3. Angle 3 is facing angle 1. So we can say that they are vertical. These angles are vertical. So we have our first pair of vertical angles is angle 1 and angle 3. Just like corresponding angles, vertical angles also have equal measures. To complete the 4 pairs, we now have the 3 pairs of vertical angles. Angles 2 and 4, 5 and 7, 5 and 7. Finally, we have angles 6 and 8. That is the 4 pairs of vertical angles. Let us now move on to alternate interior angles. From the word interior itself, these are the angles found between the 2 parallel lines, or found inside the pair of lines. Unlike corresponding and vertical angles, we only have 4 angles or 2 pairs of angles, excluding the 4 pairs of angles which are found outside, which we will be mentioning after this kind of angles. What do we mean by alternate? The idea of alternate, or the word alternate, is directly opposite to the word corresponding. If corresponding angles are found on the same exact position or location, lying on different points, alternate interior angles are 2 positions adjacent to each other. For example, we have angle 3, an alternate interior angle. Its pair is angle 5. Since angle 3 is corresponding to angle 7, and angle 7 is a vertical angle paired to angle 5, then we can say that angle 3 and angle 5 are alternate interior angles, and that would also mean that they have equal measure. So our first pair for alternate interior angles are angles 3 and 5. Following the same logic, we have angles 4 and 6, also an alternate interior angle. So these are the 2 pairs we have for the third type of angles formed in a transversal, the alternate interior angles. For the last type of angles formed in a transversal, we have the alternate exterior angles. By the word exterior, it obviously means that these angles are found outside the parallel lines. For this type of angles, we have the angles 1 and 2 and 7 and 8. Following the same reasoning we had a while ago for the interior angles, we conclude that angle 1 is paired to angle 7. And lastly, angle 2, which is located right here, is paired to angle 8. So we now have the final pair for our angles, the angles that are found on a transversal. Knowing all this, we are now ready to solve the problems that follows. Here, we now have our first problem. For what value of x will lines L and J be parallel? Or to rephrase the question, how can we prove that these 2 lines L and J are parallel? In the problem, the asked is of course the value of x, and the given we have the measures of angles which are alternate interior angles. For the first angle, we have the measure of 60 degrees, and for the second angle, we have x minus 5. Note that these two angles are found on the interior or on the inside or between the two parallel lines, and they are alternating. They are not corresponding, and they are not vertical angles. To prove that they are alternate interior angles, we can consider the third angle in which they have both a connection or relationship. And this is the angle vertical to the first given, which is the measure of 60 degrees. Since vertical angles have equal measure, we can conclude or we can be certain that this third angle also has the measure of 60 degrees. This particular angle that is vertical to the given angle with a measure of 60 degrees is also corresponding to the angle or to the second angle, which is the measure of x minus 5. So by transitive property, from this third angle, we can say that both of the given angles, 60 degrees and x minus 5, are equal, or both of these given have equal measures. So we can have the equation 60 is equal to x minus 5. Now, why did we equate the two given? These two angles we have proven to be equal because they are alternate interior angles. Thus, we have put them into an equation. Using basic algebra, or in this case, the addition property of equality, we will add the integer positive 5 to both sides. Negative 5 plus 5 is of course 0. So this expression will be cancelled, and we will be left with x now equal to 65. X equal to 60 plus 5, hence the answer is 65. So the value of x that is being asked in the problem is 65 or 65 degrees. So the measure of the second angle is x minus 5. Substituting the value of x that we now have found, it will be 65 minus 5, or equal to 60. Again, since the two given angles are alternating interior angles, they must have equal measure. And since this angle is 60 degrees, and we now have found that the second given is also 60 degrees, we can now see that they are indeed alternate interior angles. Thus, in conclusion, making these two lines, the line L and line J, to be parallel. We now have solved this particular problem. Let us move on to the next. Now, this is our second problem. Lines P and V are parallel. What is the value of x? Our given pair of angles are 3x plus 15. For the second one, we have 2x. Both algebraic expressions. We are going to look for the value of x. As you may have noticed, one angle is found on the exterior, and the other is found on the interior. So how are we going to establish the connection or the relationship between these two angles? We are going to find the corresponding angle or the third angle that is related to either of the given angles. So say we choose 2x. We are going to find the corresponding angle paired to 2x. So what is in here? What is the corresponding angle we have for 2x? 2x is located here. So its corresponding angle should be this angle. Since corresponding angles have equal measure, if this is 2x, this one will also be 2x. So now we have found the adjacent angle to the first one, the given angle 3x plus 15. The second angle, which also has the measure of 2x, is adjacent to 3x plus 15. So these two angles are adjacent angles. In geometry, we are taught that adjacent angles always have a sum of 180 degrees. In other words, if we are going to add these two angles, this should or this must result in a sum of 180 degrees. Let us try to add these two angles. 3x plus 15 plus the second angle 2x equal to 180 degrees. That is our first equation. Again, simple algebra, we will follow the same process. We will add the like terms. 3x plus 2x is equal to, and now we will transpose the sole number or sole constant 15 to the other side. It will become 180 minus 15. So we will have 3x plus 2x, that would be 5x, and we will subtract 15 to 180. 180 minus 15 is equal to 165. So we now have 5x is equal to 165. We have to cancel 5, of course. Getting the quotient, the value of x will be 33. So x is equal to 33. We will now substitute the value of x to the given two angles. If x is equal to 33, then 3x plus 15 would be equal to 33 times 3 plus 15. It would be 99 plus 15. And the measure of the angle would be 114 degrees. So the value of our, or the measure of our first angle is equal to 114 degrees. For the second given, we have 2x is equal to 2 times 33. That would be simply 66. So our second angle, or the measure of our second angle, is 66 degrees. What is asked in the problem is the value of x. So the value of x is equal to 33. Let us move on to the next problem. Now here, this will be our last problem. For our third and last problem, unlike the two previous examples, we will not look for the value of x. Instead, now here we are going to look for the actual measure of an angle. The given is the following. We have line JK and line LM. Line JK is parallel to line LM. That is our parallel lines given in this problem. We have a third line, line UV, and line UV is our transversal. What is asked in this problem is we are going to find, or we are going to look for the measure of angle Q. Angle Q is right here. The two given angles are angle P and angle O. Angle P is equal to 3x and angle O is equal to 4x minus 21. So how are we going to solve this problem? Remember corresponding angles. What are the corresponding angles in this problem? We have the two angles, angle P and angle O. They are corresponding to each other. Corresponding angles have equal measure, or they are equal. We are going to equate the two measures of angle. Angle P is equal or is congruent to angle Q. Angle P is equal to 3x and angle O is equal to 4x minus 21. we are going to combine like terms. 4x minus 3x is now equal to positive 21. So that would mean that the value of x will be 21. Now that we have found the value of x, we are going to substitute x to both of the algebraic expressions. So the measure of angle P will be equal to 3 times 21, that would be 63. So angle P is equal to 63 degrees. Since angle P, as we have already mentioned a while ago, is corresponding to angle O, the measure of angle P must be equal to angle O. So it means that angle O must be or should be also 63 degrees. Let us check. Let us substitute now the value of x, which is 21, to 4x minus 21. So the measure of angle O is equal to 4x minus 21, or 4 times 21 minus 21, which will give us 84 minus 21. And the answer, finally, we have also 63 degrees, which is equal to the measure of angle P. Now, since angle O is a vertical angle to angle Q, or angle Q is vertical angle to angle O, these two angles also have equal measure. So since we have 63 degrees to both angle P and angle O, that would mean that we also have the equal measure for angle Q. So since in this problem, what is being asked is the measure of angle Q, we have 63 degrees for angle Q. And that's it for this video. Hope you learned something. We will have more math videos to come. Thank you and God bless.